The overall goal of this procedure is to demonstrate the technique of simultaneous EEG monitoring during transcranial direct current stimulation. For that, we will describe in a step-by-step fashion all the procedures of application of this device using schematic figures, tables, and video demonstrations. The procedure begins by assembling the necessary materials and measuring the head. Next, the transcranial direct current stimulation, or TDCS, and EEG recording electrodes are positioned in the cap. Then, the electrical stimulation over the head is activated. The final step is to interpret the EEG signals obtained during TDCS.
Transcranial direct current stimulation is a technique that delivers weak electric currents through the scalp. This constant electric current induces shifts in neuronal membrane excitability that results in secondary changes in cortical plasticity. Although TDCS has most of its neuromodulatory effects on the underlying cortex, TDCS effects can also be observed in distant neural networks. Therefore, the use of simultaneous EEG with TDCS can provide valuable information on the mechanisms of TDCS.
In addition, electroencephalographic findings can be an important surrogate marker for the effects of TDCS, and thus be used to optimize its parameters and to guarantee the safety of the procedure, for instance, in children.
Compared to functional MRI, EEG has the disadvantage of spatial resolution assessment. However, it has superior temporal resolution, reflecting timing of neuronal activity more accurately. In addition, as compared with TMS cortical parameters, EEG might provide a more accurate understanding of ongoing cortical activity during and after the TDCS.
To begin the procedure, prepare all the required materials. Then, connect all the electrodes to the control box device. This device has to be charged periodically using the control box battery charger. Next, connect the control box to the computer with a USB for Bluetooth connection. For head measurement, measure the distance between the nasion and inion. Then, mark the halfway point as the vertex or CZ using a skin marker. Inspect the skin for any pre-existing lesions and avoid electrical stimulation EEG recording over any damaged skin or over skull lesions. Clean the surface of the skin to remove any signs of lotion, dirt, and grease and allow it to dry. Now soak the TDCS sponge electrodes with the saline solution. For a 25 to 35 cm squared sponge, approximately 6 milliliters of solution per side may suffice. Next, insert the TDCS sponge electrodes and the EEG electrodes in the cap. Make sure the subject is seated comfortably. Put the cap on the subject's head so that the vertex measured on the head matches the CZ point of the cap. Use a curved syringe to fill the EEG electrodes with gel. Attach the control box to the posterior part of the cap. Use channel 1 and 2 for stimulation and channel 3 to 8 for EEG recording. Their position in the cap depends on the desired experimental approach for both recording and stimulation. In this demonstration, the classical left anodal TDCS setup will be displayed. Connect the anode, indicated by the red sponge electrode, to the C3, and the cathode, indicated by the black sponge electrode, to FP2. Connect the wires to the control box and fix it to the occipital region of the cap. The control box connects to the computer through a wireless interface. To start the stimulation procedure, first click Stimulation in the horizontal bar on the upper screen. Select Edit in the upper screen and choose TDCS or sham out of other electrical stimulation techniques, such as transcranial alternating current stimulation and transcranial random noise stimulation. Then click Launch in the lower part of the screen. Check if the vertical gray bar is moving during TDCS. Electrode impedance values should be constantly monitored, and click Abort to suspend the stimulation at any moment if needed. The EEG time domain allows us to check the baseline ongoing EEG activity and select EEG band frequencies if needed. The EEG power spectrum allows us to check the predominant EEG frequency band after automatic fast Fourier transform analysis over the raw ongoing EEG activity. In the EEG spectrogram, we can transform the EEG signals into images using a technique called time frequency analysis. These figures show the differences in frontal alpha amplitude in response to active TDCS when compared to sham TDCS over the left dorsolateral prefrontal cortex.
Using the automatic fast Fourier transformation analysis, the investigator is able to determine and measure the amplitude of the predominant EEG frequency activity during and after the TDCS. Depending on the region of the stimulation and other experimental conditions, the amplitude of the specific EEG frequency bands is expected to change after TDCS. Indeed, this analysis offers a unique opportunity to understand the neuromodulatory effects in real time.
The closed-loop system application might not be restricted to patients with epilepsy only. A number of recent studies have suggested that the EEG alterations may be markers of various neuropsychiatric diseases. Therefore, a combination of TDCS and EEG could be an option for rapid detection of TDCS neurophysiological effects in order to optimize stimulation protocols.
In comparison with transcranial magnetic stimulation, that's another technique of non-invasive brain stimulation, TDCS is considered much more suitable for therapeutic goals, mainly because of its low cost and portability. However, even being portable, having a system that uses a head cap with predetermined electrode locations can standardize location of stimulation and improve results. Another advantage of its device is the possibility to stimulate more than one site at the same time, which has been found to be clinically superior to conventional stimulation according to some authors.